welcome back to my channel, and today we will look at a concept of graph theory that includes the usage of subgraphs, specifically spanning subgraphs. Okay, so first let us understand the basics of spanning subgraphs. So subgraphs means, first I will tell you what subgraphs are. Subgraphs. Okay, so you suppose you have an original graph G which has E set of edges and V set of vertices. Okay, now what you do, you from this original graph G, you pick a subset or a small portion of the vertices. For example, our G can look like this. The set of vertices may be, this is the original graph G. Okay, like this. Okay, this is our original graph G with 1 2 3 4 5 vertices, and E1 E2 E3 E4 E5 E6 as the set of edges. So G vertex set is 1 2 3 4 5, and edges are E1, E2, E2, so on, E6, E1, E2, E3, E4, E5, and E6. Now you decide to create another graph using a portion of the vertices and a portion of edges. So suppose you create another graph H, which is a subgraph, meaning a portion of vertices, a portion of edges from the original graph. So this is your subgraph. The vertices are 2, 5, 3, 4. 2, 5, 3, 4. Okay, 3, 4 order is different. 3, 4. And edges will be E4, E5, E6. Okay, there is one more edge. E1, E2, E4, E3, E4, E5, E6. Okay, E7. One more edge is there. E7. Okay, so E7, E4, E5, E6. E7, E4, E5 and E6. So our H is a subgraph of G. Okay, so there are two kinds of subgraphs, more categories of subgraph. One is a spanning subgraph, and another one is induced subgraph. So let us see spanning subgraphs first. So for this graph G, spanning subgraph will be a subgraph where the vertex set of the subgraph is same as the original graph G. That means if you create another, so if you create another graph I of the graph G such that all the vertices are same as that of the original graph. So all the 5 vertices, right? 5 vertices, 1, 2, 3, 4, 5 has to be present in this subgraph. So this is an example of a spanning subgraph. Another spanning subgraph need not be connected. The important thing is in this subgraph, all the vertices as that of the original graph has to be present. Okay. Another example of spanning subgraph would be this. Would be edges we pick E1, E2, and E7. E1, E2, and E7. Okay, 1, 2, 3, 4, 5, E1, E2, and E7. So this is also example of a spanning subgraph. So spanning means same vertices, same vertex set as original. This is the only condition. Okay, any number of edges you can pick from the original graph. Okay. Okay, next important topic is induced subgraph. What does induced subgraph mean? Okay, induced subgraph. So you pick a set of vertices, any set of small set of vertices from V. Suppose we pick, we will color it using red. We pick 2, we pick 5, and we pick 4. So 2, 5, 4. In between 2, 5, 4, whatever edges are there in the original graph, in between 2, 5, 4, what edges are there? E7, E3, and E6. All these edges has to be there. Okay. So this is an example of a induced subgraph 2, 5, and 4. Right? 2, vertex number 2, vertex number 5, vertex number 4 is there. And in between these three, whatever edges are present in the original graph, they has to be there. E7, E6, E3. So this is an induced subgraph example. What if I make the another graph like this? Let us call this K graph. Okay, like this 2, 5, 4 with E7 and E6. So this is a subgraph of graph G, but it is not induced. This is not induced. Why? Because E3 edge is not there, and in between 2, 5, 4, whatever edges are present in between these three, all edges has to be present in the induced subgraph as well. Okay, with this background, let us try to answer this question. So for a graph to be spanning subgraph, what has to be there? You have to pick all the vertices, 1, 2, all the 5 vertices has to be there. And edges have an option, they can be present, they may or may not be present, no problem. But for a graph to be a spanning subgraph, all the vertices, 5 vertices has to be there. Okay. So that means this edge in the subgraph may or may not be present. It has two options. This edge also has two options. This edge also has two options. This also two options. Two options, two options. 1, 2, 3, 4, 5, 6. The answer is 2 power 6. All the edges have an option to be present in the spanning subgraph or not. And 1, 2, 3, 4, 5, 6 edges are there. And 2 raised to the power of 6 to the power of 5 is 32 into 2. 2 is a 4, 2 3 is a 64 is the the answer is 64 only. Okay. In the question, so hope you like this video. The options are not correct. Okay, the answer is 64. The option, it should be 64. Okay, hope you like this video. Please share it with your friends, subscribe to my channel, and stay tuned for more discrete math videos. Bye bye, take care.